Farms are changing. The soil, the seed, and the skies above are the same, but the tools farmers use are getting a digital brain. From robotic harvesters and cameras that see weeds, to gene-edited seeds and solar arrays that double as shade, AI is reshaping agriculture. Today we're exploring the U.S. companies leading that revolution, how the tech works, and what it means for food, climate, and the bottom line. Robots and machine vision first saw real scale in cropping operations when major OEMs started embedding computer vision and machine learning into their machinery. A marquee example, John Deere acquired Blue River technology to add see and spray capabilities that can distinguish crops from weeds and only spray the unwanted plants, dramatically reducing chemical use and costs. This isn't future fantasy. It's deployed today in many lettuce and vegetable operations, and the same pattern is extending to row crops and harvest assistance. Guidance and autonomy are a crucial base layer. Trimble and AGCO are big names here. Trimble supplies the positioning, guidance, and mapping backbone that makes hands-free steering and centimeter-level location possible. The same pattern is extending to row crops and harvest assistance, with companies like Trimble and AGCO leading the positioning and guidance technology. AI's other superpower is prediction. Models that turn sensors, satellite imagery, and harvest records into smart prescriptions. Companies like AGCO bundle hardware and software into platforms, Fuse, PTX, that let farmers apply seed, water, and fertilizer precisely where it's needed. The economics are simple: reduce inputs, hold or raise yields, and cut environmental footprint. The capital intensity is the barrier, but adoption follows ROI, and more farmers are seeing that math. CNH Industrial bolstered their precision capabilities by acquiring Raven Industries to enhance their precision agriculture technology offerings. This integration allows for more precise application of inputs based on real-time field conditions and historical data analysis. For crops where climate control matters, herbs, greens, specialty tomatoes, controlled environment agriculture, CEAs, pack the entire growing environment into a building. AI runs lighting schedules, nutrient dosing, and robotic handling. Several U.S. companies and funds tried to scale this model publicly. Outcomes vary. Some successes, some painful lessons. AppHarvest, for example, pushed large greenhouses as a way to bring fresh produce closer to consumers. But scaling those operations profitably proved difficult. The takeaway: CEA is powerful, especially when AI and robotics lower labor costs and raise yield consistency. But the business model has to be tight. The integration of AI and robotics in these controlled environments enables precise management of growing conditions and automated handling throughout the production cycle. AI isn't just in robots and tractors, it's accelerating plant breeding. Machine learning helps breeders sift through genetic data to predict which gene edits deliver drought tolerance or disease resistance faster than old-school breeding. Corteva, a major U.S. seed and trait company, has been investing in gene editing partnerships and joint ventures to accelerate delivery of edited traits to farmers. Gene editing partnerships reduce the time from discovery to field trial, and when combined with precision phenotyping, high-throughput field sensors, and AI, breeders can iterate far faster. This combination of genetic innovation and AI-driven analysis is revolutionizing how quickly new crop varieties can be developed and tested for real-world applications. Water is life for crops. Precision irrigation systems, like Lindsay's Zematic with FieldNet, use remote management sensors and AI to apply variable-rate irrigation, so every hectare gets exactly what it needs. At the same time, farms are becoming energy producers. Co-locating solar and crops, agrivoltaics, is a fast-growing option to diversify farm income while supporting clean energy goals. Federal and lab programs are pushing the research, and pilots are multiplying across the U.S. These installations create multiple revenue streams while supporting biodiversity and sustainable land use practices. Combine on-site solar with electrified equipment, and you can shrink operating costs, run pumps and greenhouses from on-farm renewables, and reduce carbon intensity. A triple win when deployed thoughtfully. Adoption follows incentives. Larger row crop operations and specialty growers adopt faster because the ROI is clearer. OEMs, Deere, AgriTech, CNH, bundle hardware plus software as a service. Data platforms, Trimble, AgriTech Fuse, PTX, stitch multi-brand fleets together. And specialists, Lindsay for irrigation, deliver targeted, measurable upgrades. But barriers remain. Upfront capex, broadband, connectivity on rural acres, data interoperability, and the need for trusted technical support. That's why M&A and partnerships are common. Big OEMs buy or partner with nimble AI startups to combine scale plus software talent. Expect a layered stack to emerge, reliable positioning and edge computing on every machine, computer vision and robots for labor-intensive tasks, harvest, pruning, sorting, cloud AI for farm-scale optimization, and biotech shortening the time to climate-resilient varieties. And energy systems will be integrated so farms become net zero or even net positive energy hubs. Many of the leading hardware OEMs are already positioning for this stack. Deere's Robotics and Blue River move the needle on vision plus actuation. Trimble builds the positioning and mapping layer, AGCO is packaging precision services with PTX, and Corteva is accelerating trait delivery on the biology side. Meet Maria, a third-generation grower. Her system flagged a nitrogen deficit at midnight. The AI scheduled a variable rate pass at dawn. By noon, an autonomous implement completed the application, and the CEA next door adjusted LED spectra to support transplant health. That orchestration is what these technologies unlock. Speed, precision, and resilience. Technology is a tool, powerful but not neutral. Farmers, tech companies, and policymakers must work together on data sovereignty, who owns farm data, equitable access for smallholders, and environmental safeguards, so the transition benefits both people and the planet. The future of agricultural technology depends on collaborative development that prioritizes both innovation and responsible implementation across all scales of farming operations. AI, robotics, biotech, and renewables are not separate trends. They're composing a new agricultural ecosystem. U.S. companies like Deere, Trimble, AgriTech, CNH, Corteva, and Lindsay are some of the firms building the rails. The next decade will be about scaling those tools responsibly and making farms more productive, resilient, and sustainable. The transformation of agriculture through technology represents one of the most significant shifts in how we produce food and manage our relationship with the land. Did you find this information useful? If so, be sure to like this video and subscribe to join our community. It's the best way to make sure you catch our next video.